So today we're going to cover day 1 or 6A, and today we're going to learn how to solve other types of equations. The beginning examples, the solving the polynomial equations, are going to be very similar to what we did in the prerequisite chapter. So examples 1 through 9 are going to be you've seen them before. Once we get to number 10, this one will be a little bit different. So whenever we're solving polynomials, most could be factored. You should always start by factoring out the GCF first. And then remember, if the variable on the first term is the square of the middle term, then we can use what's called a U substitution to simplify the polynomial. So once we get to this third bullet point here, this is what we're going to see in number 10, and it's called U substitution. Now, coming up after this chapter, this is leading us into graphing polynomials, because all of these solutions that we're finding are really going to be our x-intercepts. So you're going to see different instructions when we get to graphing. They may say, if you ever see a question on an SAT, or even when we get into the graphing, they may say solve, or the instructions may say find the roots, or the instructions may say find the zeros, find the solutions, find the x-intercepts. All of these instructions are the same. We're just solving the polynomial. Whether we're going to use factoring, if it's a quadratic, we could use quadratic formula. You're finding what x equals. And then you could turn those into ordered pairs, and then they could create x-intercepts. So let's go ahead and try our first example. So the first one, again, we want to set it equal to 0. So I'm going to subtract the 48x squared from both sides. And I'm left with 3x to the 4th minus 48x squared equals 0. Next, I'm going to look to see if I have a GCF, and I do. My greatest common factor here is going to be 3x squared. And I always like to put the GCF underneath. You don't need to. So I'm going to divide by the GCF. And then what remains is going to be x squared minus 16 equals 0. Now, don't forget about that GCF, because this is one of my solutions. I need to set that GCF equal to 0. Now, I can keep factoring, or I could use the even root or the square root method. I'm just going to go ahead and factor. So I still have my GCF. I can factor x squared minus 16 into x minus 4, x plus 4, and now I set each one of my factors equal to 0. So I'm going to set the GCF equal to 0, 3x squared equals 0, each one of the binomials equal to 0, and now I solve each one. Now remember, this largest exponent at the beginning is going to tell me how many solutions I'm looking for. So I'm looking for 4. However, on the red GCF here, once I divide this by 3, I now get x squared equals 0. Because 0 divided by 3 is 0. When I square root this, technically I would be getting plus and minus 0, so I would be getting 2 answers here, but I only list it once. So this one is actually accounting for 2 of the answers, and then the other 2 are going to come from adding the 4, and I get x equals 4, subtract the 4, and x equals negative 4. So my 4 answers are really 0, 0, 4, and negative 4. But again, I'm only going to list the 0 once. And if you want to put on your test as plus minus 4, you can. WebAssign's probably going to make you separate it with commas. So the answer to number 1 are these 3 answers. Let's try number 2. Same thing. This one's already set equal to 0 for me. So I'm just going to factor out a GCF. And coincidentally enough, my GCF is the same on number 2. It's the 3x squared. So I'm going to divide both of them by 3x squared. And now what remains is going to be 3x squared minus 4 equals 0. Now I'm going to take each factor. Now, the 3x squared minus 4 cannot be factored any further, but I can use my even root method here. Okay, you could also do it with the quadratic formula. It doesn't matter, it's quadratic. But I'm going to go ahead and just use the even root method. That'll be the fastest. So I set my GCF equal to 0. I'm going to set what I got when I divided equal to 0. I'm going to solve each one. X squared equals 0. Remember, you're square rooting here. So really what's getting out of this is two answers, plus and minus 0, but there is no plus and minus 0. Here, I'm going to go ahead and add the 4. And I get 3x squared equals 4. Remember, we want to isolate the square term. So I have to divide by 3 first. And then I get x squared equals 4 over 3. I need to square root both sides. Now, if it's easier for you to think of this square rooting them separately, then I get x is equal to plus and minus, don't forget, 2 over the square root of 3. Remember, you can never ever leave a square root in the bottom of a fraction, so I need to rationalize this. So I'm going to go ahead and multiply the top and the bottom by the square root of 3. And then this finally gives me x equals plus and minus 2 square root 3 over 3. So I was looking for 4 answers, but remember on that GCF, x equals 0 counts for 2 of them. Remember, all of these x values, we can turn them into ordered pairs, and they're going to end up being our x-intercepts. Let's go ahead and try number 3. Notice it's a 4-term polynomial. So first thing I'm going to always do is check to see, is there a GCF I can divide all 4 by? There's not. So I'm just going to factor by grouping. So I'm going to go ahead, let me just rewrite it. X to the third, 3x squared, plus 3x minus 9 equals 0. I'm going to make 2 groups. My greatest common factor of my red group is going to be x squared. I'm going to divide, and then I'm left with x minus 3. My GCF of blue is going to be positive 3. Take your 2 GCFs that you found. That becomes the first binomial. And then the one that's in common is the second. So then these 2. And now I set each one of these factors equal to 0. So x squared plus 3 equals 0, and x minus 3 equals 0. Subtract 3. I'm going to get an imaginary solution on this one. Square root both sides. This becomes x equals plus and minus. The negative 3 becomes I square root 3. And then over here, add the 3, and x equals positive 3. So I have 2 imaginary solutions and 1 real solution. Notice the highest power was x to the third, telling me I needed 3 answers. The next one is also factor by grouping. This is all what we've already done in the prerequisite chapter. Nothing new yet. So I'm going to factor by grouping here. You rewrite my equation. X to the third minus 5x squared minus 2x plus 10 equals 0. I'm going to make a red group and a blue group. My greatest common factor of red is going to be x squared, x minus 5. My GCF of blue, now if I pull out a positive 2, what's going to end up in the parentheses will not look the same, so I'm going to pull out a GCF of negative 2, and now it looks the same. So now I take the 2 GCFs I divided by, they become the first binomial, and then the one that's in common, what I got when I divided. Set each of the binomials equal to 0. Add 2. x squared equals 2. X squared equals 5, or just x equals 5. Square root both sides, and I get plus and minus the square root of 2, and then the x equals 5. So 3 solutions, 2 that are radicals, and then the 1 integer. So number 5, again, always look for a GCF first. This one actually has a GCF that I can divide all 3 terms by, and my GCF is going to be 3x. I'm going to divide all 3 by 3x. Do not forget about that GCF. It ends up being one of my solutions. So now after I divide, I'm left with 2x squared minus 9x minus 18 equals 0. Now, what's in the parentheses, that trinomial can still be factored further. Now, even if it couldn't be factored, then you would do quadratic formula or completing the square. You don't just stop. So at this point, this one can be factored. You can either guess and test. I'm actually going to factor by grouping. So I'm going to go ahead and multiply the first and the last, and I get negative 36. So factors in negative 36 that when I combine them give me negative 9. So 2 numbers multiply to give me this, but add to give me this. So if I start my organized list, I know my signs need to be different. So 1 and 36, and it's negative 36, 2 and negative 18, 3 and negative 12, and that's my magic combination. So let me go ahead and change my polynomial, my trinomial into a 4-term polynomial. So I'm going to go ahead and rewrite everything. So 3x, rewrite the first term, replace the middle with the 2 factors I just found. So positive 3x and negative 12x minus 18. And now let's make groups. So I got a blue group here. Let me do a different color, purple. So blue and purple. Now that GCF is still out front. I just keep writing it down so I don't forget about him. So now my GCF of my first group is x. So if I divide these by x, I get 2x plus 3. My GCF of purple, in order to make them look the same, I'm going to pull out a negative 6. So now put the 2 GCFs together. So the x minus 6 is the first binomial. And then the 2x, and my signs are off here. The purple needs to be a plus sign. And again, don't forget about the 3x in the front. Let me go over here to the side. So now I take each one of the factors and set them equal to 0. So the 3x, the GCF, then the x minus 6, and then the 2x plus 3. Divide by 3. My first solution is x equals 0. Add 6, x equals 6, and then subtract 3, 2x equals negative 3, divide by 2, and x equals negative 3 over 2. Notice it was a power of 3, so I have 3 answers here, 0, 6, and negative 3 over 2. For number 6, even though it's raised to the 4th power, I can actually just factor that into x squareds. So let's try number 6. So what I can do here is the x to the 4th becomes x squared and x squared. And then the factors of 2 are 1 and 2. But they both have to be negative in order to get a negative 3 in the middle. So now set each of the factors equal to 0. Actually, I can keep going on this one. Let me factor this one first. X minus 1, x plus 1. This one can't be factored any further. So now set each of your factors equal to 0. You could have also done the square root method on that first one, on that difference of two squares. So here I'm going to add 1. My first solution is 1. Subtract 1, negative 1. Add 2. X squared equals 2. Square root it. X equals plus and minus the square root of 2. Now WebAssign is going to make you separate them all with commas. On the test, if you wanted to just take these two and list them as x equals plus and minus 1, you could do that as well. So we have 4 solutions because notice my largest power at the beginning was an x to the 4th. Next one, I'm going to do exactly the same thing. So it's x to the 4th. So again, x squared times x squared gives me the x to the 4th. But then I need to look for factors of 12 that give me negative 7. And that's going to be negative 3 and negative 4. Again, the x squared minus 4 is the difference of two squares. So I can keep going on that one. Or you can use the square root method. Either way, I'll go ahead and factor it. X plus 2, x minus 2. Now set each of the factors equal to 0. Solve by adding 3. I'm solving for an x squared, so I have to square root it. So x is equal to plus and minus the square root of 3. Here I'm going to add 2. X equals 2. Subtract 2. X equals negative 2. So again, if you want to just put it as plus minus, here are your 4 solutions. But again, WebAssign is going to make you pull it apart. Number 8, and I've written all over the place, so I'm going to rewrite it down here in the bottom corner. At first glance, you might think it's a perfect square trinomial, but if you try the trick and you try to square root them and double them, it doesn't give it to you. So we actually have to factor 4, and instead it's going to be 1 and 4 as the factors. But let me go ahead and rewrite it down here. So I have 9x to the 4th minus 37x squared plus 4 equals 0. So my factors in 9 are going to be 9 and 1. You can also try 3 and 3. On this one, I'm just going to guess and test. You could also have factored by grouping. You would have gotten 36 and 1, both of them negative, and then make your groups. But I'm going to guess and test here. So factors in 9x to the 4th are going to be 9x squared, and then just 1x squared. And then my factors of 4 are going to be 1 and 4. But again, you could have done this with grouping. I'm just going to do it fast because these are both the difference of two squares. So now I have to keep going. 3x minus 1, 3x plus 1, x minus 2, x plus 2. Set all 4 factors equal to 0. 3x minus 1 equals 0. 3x plus 1 equals 0. X minus 2 equals 0. And x plus 2 equals 0. So add 1. 3x equals 1. Divide by 3. X equals 1/3. Subtract 1. Divide by 3. X equals negative 1/3. And then over here, add 2. Subtract 2. So final answer, you can write it as plus and minus 1/3 and plus and minus 2. Either way. All right, number 9, rational. So we got a fraction. So what we want to do is clear the denominator. So what I'm going to be doing is my common denominator is x squared. So I'm going to be multiplying all 3 fractions by x squared. If you want to write it next to each one, you can. or you can just write it out in front of the whole thing. And just remember, you're distributing it to each. So you're distributing it here, here, and here. Now, it might be easier if you write the x squared next to each one. And then you can see what cancels. It's totally up to you. All right, so we're trying to get rid of the denominator. So this becomes x squared. This, the square cancels. So then I'm just left with plus 3x. And then the answer here, the x squareds cancel. And then I'm left with equals 2. So now I need to get this into a trinomial that I can factor, potentially, if not, quadratic formula, but this one's factorable. Honestly, factoring is the fastest way once you get, really good at finding these factors. So my factors of 2 that give me 3 are just going to be 1 times 2, because 1 plus 2 gives me 3. So set x plus 1 equal to 0, x plus 2 equals 0, subtract 1, and I get x equals negative 1, subtract the 2, negative 2. Notice when I plug those in to either x or x squared at the beginning, it doesn't make anything 0, so both answers are good. So remember, you have to check when it's rational. So we're checking the denominator. It cannot equal 0. Now the new stuff, the u substitution. Now, I'm going to show you what I did on the previous examples when it was x to the 4th. You can do it that way when it's nice and easy, but I want to show you the introduction when it's an easy trinomial with the u substitution, and then, because they're going to get more complicated, where it'll be mandatory that you do the u substitution. So on number 10, it's optional. I'm going to go ahead and first just do it like I did the other problems. My factors of x to the 4th are going to be x squared. Factors of 2 that give me negative 3 are going to be negative 2 and negative 1. This one can't be factored any further. This is the difference of 2 perfect squares. And then you get x squared minus 2 equals 0, x plus 1 equals 0, x minus 1 equals 0. Solve each one. X squared equals 2, square root it, and x is equal to plus and minus the square root of 2. Over here, subtract 1, add 1 on this one. So my 4 answers are plus and minus the square root of 2 and plus and minus 1. Now, let me show you how to do this with u substitution, because when we get radicals, when you get like fraction exponents, then you're going to have to do the u substitution. So let me show you the same problem now using the u substitution. So I'm going to come over here to the side. Let me rewrite the problem. X to the 4th minus 3x squared plus 2 equals 0. So what I'm going to do here is I'm going to use what's called u substitution. Really, you can use whatever letter you want. So what I'm going to be doing is setting u equal to this middle term's variable. So u is going to equal x squared. So then u to the 4th, so if I take that u and square it, then it becomes this. And power to the power, u squared is equal to x to the 4th. This is just the thinking behind it. So now what I'm going to do is I'm going to take out this, and I'm going to replace them. So that is going to get replaced with the u, and then this x to the 4th is going to get replaced with u squared. So then what we're going to do is rewrite this as u squared, and the coefficient stayed there, minus 3 u, and then the 2 stays there, equals 0. And now I factor u minus 1, u minus 2 equals 0. We're going to solve for u. Add 1. U equals 1. Add 2. And u equals 2. And now what I have to do is take what I set u equal to, and I'm going to put in here x squared. I'm replacing u with what I set it equal to. And now I square root. X is equal to plus and minus 1. And x is equal to plus and minus the square root of 2. Now, honestly, the first way was easier on this polynomial, but coming up on examples 11, 12, 13, and 14, you're going to want to do, or 11, 12, and 13, and actually 14, you're going to want to do the u substitution. It's not optional. So let's try it. This is what's new now. So for number 11, I'm going to set u equal to this middle term. So my u is equal to x plus 1 raised to the 1/3 power. So again, if you think about it, if u equals x plus 1 to the 1/3, then when I raise this and I square this and square this, u squared becomes x plus 1 to the 2/3 power, which is what I have there. So my new equation to factor is going to be u squared minus u minus 2 equals 0. So what I've done is I've replaced u squared, or put u squared in for that one, and then my u was the x plus 1 raised to the 1/3. Now it's a lot easier to factor. Factors of -2 that give me -1 are u minus 2, u plus 1. Solve for u. U minus 2 equals 0. U plus 1 equals 0. Add 2. U equals 2. Subtract 1. U equals -1. So now I don't want to solve for u. I want to solve for x. So now I got to put back in what I set u equal to. And u is equal to x plus 1 raised to the 1/3 power equals 2. And then over here, x plus 1 raised to the 1/3 power equals -1. Now, in order to solve a fraction equation or a rational exponent, I need to raise both sides to the 3rd power. So I can keep things balanced. So I'm going to multiply this side and raise it to a power of 3 because this cancels. And then I'm just left with the x plus 1. But I have to do 2 to the 3rd power. So then now I get 8. And then I can solve this. And I get x equals 7. And then over here, I'm going to do the same thing. Raise both sides to the 3rd power. The x plus 1 comes out. And then -1 to the 3rd power is just -1. Subtract 1. And x equals -2. Number 12, I'm going to do exactly the same thing. I'm going to set u equal to just this, not the coefficient. So u is going to equal 2x minus 1 raised to the 1/3 power. So my equation that I'm going to be factoring is going to be u squared plus 2u minus 3 equals 0. I'm looking for factors of -3 that give me positive 2. It's going to be positive 3 and -1. I'm going to solve for u first. And then I'm going to plug back in what I set u equal to. So add 1. So now I'm replacing the u with what I set it equal to at the beginning, which was that purple. So 2x minus 1 raised to the 1/3 power. And then I have 2x minus 1 raised to the 1/3 power equals positive 1. In order to get rid of that rational exponent, I'm going to multiply or raise both sides to the 3rd power. So then negative 3 raised to the 3rd power is negative 27. And then over here, positive 1 to the 3rd power is just 1. So now I can solve each equation by adding 1. Negative 26 divide by 2, x equals negative 13. Over here, add 1. Divide by 2. And x equals 1. Yes? Whenever you have binomials raised to a rational exponent, or even if you have fractions or radicals, this is where you're going to want to use the U substitution. Otherwise, it's going to be very challenging to try to solve those. So let's try 13. It's a rational equation. So again, you're setting U equal to this middle term, not the coefficient, just the fraction here. So x over x plus 1. So again, I'm going to, this will be my U squared. So 6U squared plus 5U minus 6 equals 0. Now, you can factor by grouping. I'm going to guess and test. It's going to be 2 and 3 for both. But you could do grouping. You could multiply and get negative 36. Factors of negative 36 that give you 5. But I'm going to guess and test here. 3U minus 2 and 2U plus 3. If you guess and test, you really need to FOIL it and make sure it does go back to the middle. And mine does. So now I'm going to solve for U by setting each binomial equal to 0. Add 2. Now, common mistakes I'm going to see on the test are once people find the value of U, they're going to think they're done. And then they forget that they had to plug it back in and find X, not U. So just be careful. So here, my two values of U are going to be 2/3 and negative 3 over 2. Again, I need to go back, replace U with what I set it equal to at the beginning, which was x over x plus 1. Set both of them up. Now, whenever I have two fractions equal to each other, I'm just going to solve this as a proportion. You could multiply both sides by 3 and by 2, but it's a lot easier whenever you have two fractions equal to each other. Solve this as a proportion. Just do the cross products. So this will give me 3x is equal to 2x plus 2. And then I can solve, subtract 2x, and I get x equals 2. Same thing on this one. Multiply diagonally, do the cross products. And then here I get 2x equals negative 3x minus 3. Add the 3x. 5x equals negative 3. Divide by 5. And x is equal to negative 3/5. Notice none of these are going to make any of my denominators a 0, so they're both good. And then the last one is a radical. I'm going to go ahead and set my U equal to that middle term, which is the square root of x. So this is my middle term. So U is going to equal the square root of x. Now, if you think about it, if I took this and I square both sides, squaring the radical makes it disappear. So that's how my U squared becomes x, which is what my first term was. And then I just put the coefficient. So I'm going to go ahead and replace the 6x with the 6u squared. Then the middle is 7u minus 3 equals 0. Now, again, I'm going to just guess and test here. You can factor by grouping. Factors in negative 18 that give you negative 7. That's going to be negative 9 and positive 2 if you do the grouping. But I'm going to just guess and test here. My factors of 6u squared are 3u and 2u. Factors of negative 3 are going to be positive 1, negative 3. Again, FOIL it. Make sure that you put the 1 and the 3 and the 2 and the 3 in the right spot. So set each factor equal to 0. Solve for u first. 3u equals negative 1. Divide by 3. U equals negative 1/3. Over here, do the same thing. Find the value of u. And u equals 3/2. Now again, you're replacing the u now with what you set it equal to at the beginning, which was the square root of x. And then here. Now on this one, we don't want a negative number underneath our radical. But if you go ahead and square this, you get x is equal to 1/9. But again, it's not going to work out. And even when you see that the square root of x is equal to negative, it's not real. So you could stop there. And then here you're going to square both sides. And then this is going to equal 9/4. So that's your good solution. And that is it for the notes on 1.6a.